Hello everyone, this is Kuldeep from Bennett University. Today I want to talk about first come first serve scheduling algorithm. It's one of the simplest algorithm for scheduling processes. So let's start. The definition of the scheduling algorithm goes like: the process which arrives first at the ready queue is firstly assigned to the CPU. Its advantages are that it can be easily implemented using the stack data structure, and it does not also lead to the starvation, a problem we mostly experience in the prioritizing other scheduling algorithms. Now, like many other scheduling algorithms, it has its own disadvantages. For example, it does not consider the priority or the burst time of the processes. That is, like, it's not the algorithm we would want to use if we want to prioritize the process for our needs. For example, if I want to schedule our algorithm based on my own priority and my needs, I won't be able to do that, as it's only do the basic thing. Whichever process arrives at the ready queue first, it will execute the first only. Now, it also suffers from the convoy effect. The convoy effect is nothing but a situation, like suppose that that processes with higher burst time arise before the processes with smaller burst time. Now, the smaller burst time processes have to wait for a long time for the long processes to finally release the CPU, making multiple processes late in comparison to the other algorithm. For example, if we see in the shortest job first algorithm, we won't face this convoy effect, as not multiple processes have to wait. Whichever the small process comes, it just executes that. Now, those small processes won't have to wait for the longer ones to stop. Like in a long run, the situation can be very effective. Now let's take an example. Take a problem. In this example, I have considered 5 processes with the arrival time as given, and these are the burst time I've considered. And this is a problem statement only, and we got to find those average time and average waiting time. We got to find everything. Now let's prepare the Gantt chart of it. It says that it's the FCFS. So we will first see which algorithm is arriving first. Now this is the C, which is arriving the first with time 0. So at time 0, C is arriving, and when it will execute it after burst time of 2 at 2. Now we'll see the now which of the algorithm is now arriving first. It's the 3 with the least time, with the least arriving time. It is A. Now at 3, now from 2 to 3, the CPU will remain idle, and at 3 the process A will start to be executed, and up to 7, as the burst time is 4, 3 plus 4, 7. Now the arrival time is given 4 and 4, which is the least for both. Like both are equal, which is not really possible. Like it's not a very logical statement to say that 2 are the processes which are arriving at first. So I've just taken it to clarify the concept. To get in more detailing, if I fuss about it more, can you really launch 2 apps in your mobile phone at the same time? Like, can you really click on the Instagram and Twitter at the same time and launch them? No, it's not possible. We have to just, like, you can do that. So 2 processes just cannot arrive at the CPU, cannot arrive at the ready queue at the same time. Just to clarify it, so now I can just take any of those. I decided to take P. After the burst time of 2, it gets executed. Now at 9, I've took D. I had to, and at 5, as you know that E was arrived, so now E is being executed with the burst time of 1. Recap it. Arrival time the least. We will select the least with the arrival time 0. Started. Now leave it. Now leave the process we executed, and then we will keep on. Now we will make the table. Like we will fill up we have to find the turnaround time now. The turnaround time is nothing but we will subtract from the execution time and the arrival time. Like at what point the process was ended, and we will subtract that time with when was it arrived. For example, in the first process A, where is A? We would refer to the Gantt chart, which is here. A at 7, we know that it got over 7, and when it was arrived at 3. 7 minus 3, 4. Now let's look at the B. Where's the B? B is here. Where was it ended? Here, 9. Where B was arrived? 4. 4. Point to be noted that the turnaround time has nothing to do with the burst time. Just nothing had to do with the burst time. And now let's look at the D, and where's the D? Here it got ended at 11. And where was it arrived? At 4. 11 minus 4. Similarly this. Now the waiting time. Now we have to include the burst time for this. The formula goes like waiting time equal to turnaround time minus the burst time. Simple. The turnaround time, 4 minus 4, 5 minus 2, 2 minus 2, 7 minus 2. Simple, very basic. And given that we made the table, if we were to ask about the average time, average turnaround time, we will add up all and divide by 5, and similarly with the waiting time. So that's been it. Thank you for watching. Peace. See you.